Imagine a mountain, silent for centuries, a sentinel of stone and earth. It stands as a testament to time, its peak often shrouded in mist, its slopes alive with forests teeming with life, a vibrant ecosystem thriving in seeming tranquility, and rivers carving paths through the landscape, nourishing the land with their cool, clear waters. People have lived in its shadow for generations, building their homes and lives in the fertile valleys below, never suspecting the power beneath their feet, the immense, slumbering energy that lies dormant, waiting. But deep below, pressure builds, molten rock churns, a subterranean ocean of fire and fury, a force ready to reshape the world, a geological titan stirring from its age-long sleep. The ground trembles, a subtle warning, an almost imperceptible vibration. Animals sense it first, their instincts honed by millennia of survival, fleeing to higher ground. A wisp of steam escapes the summit, a ghostly plume against the azure sky, a sign of the awakening. The sleeping giant is waking, stretching its limbs of fire and stone, preparing to unleash its might. Suddenly the mountain erupts, a cataclysmic explosion, a rupture in the Earth's crust. Ash, a suffocating blanket that blots out the sun, a rain of gritty particles. Gas, poisonous fumes that choke the air, a toxic breath from the Earth's core. And rock explodes skyward, projectiles of destruction hurled into the atmosphere. In a deafening roar, a sonic boom that shatters the silence, a primal scream of the planet. This is the planet breathing fire, its molten heart exposed, a raw display of geological power, a force that can build islands, creating new land masses from the depths of the ocean, or erase civilizations, burying entire cities under layers of ash and lava, a stark reminder of nature's dominance. The peaceful landscape becomes chaos, a scene of devastation and destruction, transformed in an instant. Molten rock lighting the sky, an infernal glow illuminating the night, a spectacle of terrifying beauty. We're witnessing a fundamental process of planetary evolution, the very forces that shaped our world, a volcano erupting, a reminder of the power that lies beneath our feet. But this isn't random. There is order in this chaos, a pattern to this seemingly destructive event. It's governed by the same laws that shape the stars, the universal principles that dictate the cosmos. To understand volcanoes, to decipher their secrets, we must delve deeper. We must journey downward, into the heart of the planet, into the fiery depths, into Earth's interior, exploring the layers of rock and magma that lie beneath the surface, and back through time, tracing the history of volcanic activity across millennia. We become detectives, piecing together the puzzle of the Earth's fiery past, piecing together clues from lava flows, analyzing the solidified remnants of past eruptions, and seismic waves, interpreting the vibrations that ripple through the Earth. So, come with me. Let's embark on this journey of discovery together. Let's explore the science, the intricate mechanisms behind these magnificent forces of nature, and the profound impact they have on our planet. What secrets do volcanoes hold? What can they tell us about the Earth's past and future? The ground beneath us is alive, pulsating with energy, a dynamic and ever-changing landscape. And it's ready to tell its story, a story written in fire and stone, a tale of creation and destruction. A volcano isn't just a mountain. It's far more complex than that. It's not simply a peak rising above the landscape. It's a rupture, a vulnerable point, in the planet's otherwise solid crust, a place where the Earth's internal forces find a release. It's a vent, an opening, where molten rock, superheated and under immense pressure, ash, and a cocktail of noxious gases escape from the fiery depths, from deep within the Earth. The iconic cone shape, that classic image of a volcano, is built slowly, painstakingly, by countless eruptions over vast stretches of time. Layer by layer, each eruption adding to the growing structure. Volcanoes tend to cluster along the edges of tectonic plates, along those dynamic tectonic plate boundaries, where Earth's crust is constantly under stress, cracking and shifting in response to immense forces. But sometimes, defying expectations, they form far from these boundaries. In the seemingly stable middle of plates, in places like Hawaii, a volcanic paradise over hotspots, those mysterious plumes of intense heat, plumes of superheated rock rising from deep within the mantle, punching through the crust, relentlessly pushing upwards. As plates slowly drift across the globe, these hotspots leave behind trails of volcanic activity, creating chains of volcanoes, each island and seamount telling a story of Earth's restless interior and its geological history. Every volcano, regardless of its size or shape, from the perfectly symmetrical cone of Mount Fuji to the sprawling shield volcano of Mauna Loa, is a window, a direct connection, into our planet's dynamic and ever-changing heart. They serve as a constant reminder that Earth is not a static, unchanging rock, but a living, breathing planet, constantly reshaping itself through volcanic activity and other geological processes. Even the very air we breathe and the vast oceans that cover our planet owe their existence, at least in part, to the gases released during ancient volcanic eruptions billions of years ago. Volcanoes are not just mountains rising above the horizon. They're the architects, the builders, the sculptors of our world, constantly shaping and reshaping the landscape around us. To truly understand the awesome power of volcanic eruptions and the forces that shape our planet, we must embark on a journey deep inside the Earth, peeling back the layers to reveal its inner workings. Our planet is meticulously layered, starting with a solid core, a sphere of intensely hot, dense metal, surrounded by a liquid outer core, a swirling ocean of molten iron, and then a vast mantle composed of hot, slowly moving rock, extending thousands of kilometers. Heat, largely generated from radioactive decay, drives powerful convection currents within the mantle, like a giant engine churning beneath our feet. It is here, deep within the mantle, that magma is born. Molten rock formed in specific zones where the temperature and pressure conditions are just right for melting, particularly at plate boundaries, those dynamic zones where Earth's tectonic plates interact. Pressure drops significantly, or the presence of water dramatically lowers the melting points of rocks, creating vast quantities of magma. Magma, being less dense and lighter than the surrounding solid rock, begins to rise slowly, making its way upwards and eventually collecting in large underground chambers. These magma chambers can simmer and evolve for thousands, even hundreds of thousands of years, behaving like immense pressure cookers deep beneath the surface. Inside these chambers, magma is not a uniform liquid, but rather a complex mix of molten minerals, dissolved gases, and suspended crystals. Sometimes, under the right conditions, the magma cools and solidifies underground, slowly forming granite and other intrusive igneous rocks. Other times, a fresh injection of new magma into the chamber raises the overall pressure. As the magma cools, dissolved gases begin to separate and build up, increasing the internal pressure, effectively priming the volcano for a potential eruption. The stage is now set for a dramatic and potentially explosive release of energy. The volcanic engine is primed and ready to unleash its power. The magma chamber is under immense pressure. When the rock above fractures, magma surges upward through cracks. As it rises, pressure drops. Dissolved gases rapidly expand, like opening a shaken soda. This expansion drives explosive eruptions, propelling magma skyward. The process accelerates, more bubbles, faster ascent, more power. Lava bursts through vents, shattering rock and launching debris miles high. The volcano becomes a cannon, gases the gunpowder. Whether the eruption is gentle or catastrophic depends on magma's thickness and gas content. What kind of show will this volcano put on? Not all eruptions are alike. Effusive eruptions, like those in Hawaii, produce rivers of fluid lava, spectacular but relatively gentle. Explosive eruptions, fueled by thick, gas-rich magma, unleash ash clouds and pyroclastic flows, devastating everything in their path. Mount St. Helens in 1980 was a classic explosive eruption. Plinian eruptions can blast ash 20 miles high, affecting global climate. The deadliest product is the pyroclastic flow, a superheated avalanche impossible to outrun. Between these extremes are Strombolian and Vulcanian eruptions, each with unique bursts and blasts. A volcano's style depends on its underground chemistry, magma's composition, temperature, and gas. The type of volcano near you reveals the geology beneath your feet. Each eruption tells a story of Earth's inner workings. History is shaped by great eruptions. Mount Vesuvius buried Pompeii in ash, preserving a moment in time. Krakatoa's 1883 eruption was heard 3,000 miles away, triggered tsunamis, and cooled the planet. Mount St. Helens erupted sideways, flattening forests and revolutionizing volcanic science. These events remind us a single volcano can change the world. Supervolcanoes, like Yellowstone, have unleashed eruptions thousands of times larger, capable of plunging Earth into volcanic winter. While rare, their potential impact is immense. Volcanoes have shaped landscapes, climates, and civilizations. Their power is a reminder of Earth's restless energy, and their story is far from over. How do we predict eruptions? Volcanologists monitor volcanoes' vital signs: earthquakes, ground swelling, and escaping gases. Seismometers detect tremors as magma moves. GPS and satellites measure ground deformation, tiny bulges that signal rising magma. Scientists analyze volcanic gases for clues about what's happening below. By combining these signals, they build a picture of the volcano's plumbing. This allows for warnings and evacuations, saving lives. The work is dangerous, but vital. Volcanologists are our early warning system against Earth's fury. Their discoveries help us understand and live with these powerful forces. What mysteries will science uncover next?